previous video, we've looked into the basic of the nesting in Cadwork 3D using the nesting module. We've also seen other aspects such as the rule-generated nesting volume, basically creating therefore this way the different sizes of the nesting volume you can be using during your optimization. We are going to use this knowledge today to introduce you to OptiPanel. OptiPanel is an external nesting program available with Cadwork 3D. If we go here to Tools and opening the Nesting Manager, currently here we see the current result we have in our past optimization. Let's go ahead and delete this one. I'm just here deleting my group, and I'm going back here to my main panels. I will here, the first step are exactly the same as what we've seen before. Basically, you create your group. You can sort them based on specific attributes and things like this. Create new panel nesting. And here we are going to check directly with external nesting. There is in this window something important to talk about that we are not going to address during this example, but simply quickly right now. So in here in external nesting configuration, there are some settings that allows you to share information from the 3D with OptiPanel. There is here among extra setting an option here that should be left check, and I'm going to explain you what this one is. Basically in Cadwork, we know that if I'm opening here this other example, we know that based on production numbers, the element might be identical but maybe belong to different story or having different information such as group and things like this, as long as of course this information were not considered as sorting or possible criteria in the production number calculation. So here it means that we have among elements of the same production numbers actually different set of attributes. If we would like to actually consider these attributes during the optimization, preventing elements of different groups to be optimized together. So here basically I want to optimize this group and then that group. I don't want actually to create two separate panel nesting using the option here we've seen in the other video, allowing us to generate the group and sorting according to specific attributes. Here I want all of them to belong to the same group, and simply when running the optimization in OptiPanel, I want to prevent elements of different attributes to be optimized in the same panel, but all that in one single calculation. So here the thing is, I have actually different group. So if I want to consider this group during the optimization in OptiPanel, I need to make sure when I send that to OptiPanel that I do have actually this option activated, just to make sure that if I have several elements number 1 exported, that they will be exported individually with all of them their own set of attributes. Just keep this in mind. This is something that I'm going to briefly mention again during this video. If you don't own yet OptiPanel, just click here on the 3 dots and you will be able to apply for a 1 month free trial for you to test OptiPanel. And here let's go and create that group, and OptiPanel will then be opened after this short position control verification. We are now in OptiPanel. In OptiPanel you have here your stock that can be used. So you can create your own one, you can load existing ones, and basically you go from step after step all the way to the result. To create your stock, we've seen in the past, we've seen in a video with the rule-based volume that when using such rule and importing to OptiPanel, your panel will here be generated for you to use directly in your optimization. Here, let's not use this and check out the other option OptiPanel has to offer. So here, as it is in Cadwork, every time you have a doubt about a specific option, simply leave your mouse on top and it's going to let you know what the button is about or what this option is about. If we add a specific stock that we would like to import, we can simply open and load different file, including CSV file, if you would like to generate the stock directly from an Excel sheet. So the difference between open and import is that import will add elements. You will be able to import several stock. When opening, simply load a whole stock. You can here save, of course, and save as default storage, meaning that no matter what you have here available, if you save that, it will be available for your next optimization right away without having you to import that. Let's create here a new panel. So there is here two options. You can create a new panel, and here you will need to fill out all the different information from the name of the panel to the width and length to the thickness, material, quantity, etc. This is pretty straightforward. One thing here is, as you can see in my step 2, where I have all my elements listed, I'm working only with CLT elements with a thickness of 5.5. Here you can actually sort element by material, and here we see that they are all made of CLT. You can always add additional column to any of these tables using here the gears that you have at the bottom. Let's here add the material. So here basically we need to have CLT panel 5.5 thick, and we are going here to go to like a 60 feet long beam, 10 feet wide. So when you go back to the stock, you can here use this option. What this one does is it actually fetch information from here. It's just going actually to take the material and the thickness. It's not going to use the current format here to propose you different stock according to the shape of those ones. So here, automatically, if you have several material and several thickness in among your element, you will have here, of course, several lines. So here you can create it or not with width. So basically you have the greatest width and greatest length available here. Let's go with a 60 feet long, and here create the row panel. So here we have only one length. As you can see here, we have length increment. So this was here not an option, but this is something that you would have been able to do here right away using the incremental panel option. Or here simply, if you would like to make one of your volume incremental, you will first need to display this column. If they are not shown by default, simply here use the gears and add the length increment and the maximum length option. So here, if you would like to then change this setting, you can see that you cannot really directly change things here. It won't allow you to do so. So simply, as explained here, simply right click on the line and press edit. This will open the same window we've seen when creating panel from scratch. We are here going to activate the option incremental panel. So here, shortest length, let's say that we don't want to produce anything below 30 feet. Greatest length will be 60 feet, and we want an increment of 6 inches. You can of course apply a cost, and if you have a limited stock, you can here set the quantity. We're here just going to add the unlimited option. If you would like to create something with our element with also different widths, as here we have only 11, let's say that we would like to produce also 8, 9 and 10 feet. You will need to right click and duplicate these panels, since there is no incremental width available at the moment. Now that the stock is done, again you can save it for later, using it as your default storage, meaning that the next time you are going to start the project, you will start directly with your stock. Now, if we move to the next step, we have here different options available. First, of course, is the display of all the information. Here, as you can see, we have element of always in the same story, different production numbers. What's important here is these three columns. Fiber direction can be rotated and is flippable. This will actually impact your result. Fiber direction, simply how the element is oriented in the nesting volume. As you can see here, by default it comes as none. If you would like to change that for one element, you can simply right click on this and change these values. If you would like to change more than one item, you can simply select them all with a Ctrl-Shift click, right click on one of them, and here you can actually change all of them at once. Is flippable? Here we could say actually yes, because we would consider, for example, none of this panel to be with an architectural finish. So they are taken from a panel that is actually perfectly symmetrical. So the top face and bottom face are actually made of the same material with the same lamellar orientation and the same finish. If that were not the case, you will actually leave that as not flippable, meaning that the element will always be placed with the same orientation as they have in 3D. So all the elements will all have the thickness oriented in the same direction in the nesting volume. This option here can be actually changed in your main settings. So let's have a look. In configuration and setting, we are not going to go through all the options here. Some of them are pretty clear, but if you are looking to change, for example, the unit, so if you are using metric or imperial, this is the location where you are able to do so, changing also the surface unit, the currency you would like to use, and so on and so forth. Here we want actually to change the default values for piece coming from Cadwork 3D. So here default wooden fiber direction set to none. We could actually always force it to length and save that in our init, so that this next time we start the project again, we will always have this oriented as we would like. All our elements can be rotated 180 degrees. Basically we don't want to force the length in one specific direction. And here, by default, we don't want them to be flippable. We want to say if it is okay, making sure that we don't make any mistake. For the following one, how OptiPanel is looking, like the different colors and things like this, what could be interesting is drawing flowing data. So this is everything that you can actually have showing on your element here on the right side. So here my name is empty, so it's here not useful to actually display that, but we could go, for example, with like material. If we add element of different material, it's easier for us to track what this one is. You can see that you can add a lot of different elements, from item list number to assembly number to story and so on and so forth. Here we will see during the optimization that there is an option to actually recover offcuts. And with this option, you can actually set the value from which you consider an offcut to be something that you will be able to use, so something that you want actually to keep and save directly in what we call the bin. So you can actually add that to your next optimization. And here we are not going to look into yet the optimization setting, and simply close this. If we move here to the third step, optimization, which actually we can also go with directly the top arrow. Among the three available algorithms, the first one here is rectangular pieces only. I'm just going here to explain to you the difference between these three and then show you some examples. Rectangular pieces is simply, as it says, is no matter the shape of the element, we are only going to consider the rough rectangular shape of all elements in terms of nesting. Meaning that if you have like a gable wall or a triangular shape element, we will still consider them as rectangle, meaning that this will produce more waste, but this all depends on the way you want to cut things. So you can use the rectangular piece or the polygonal pieces if you'd like actually to be able to use the real size of the element or the real shape of the element in the calculation. So rectangular pieces, here there is different options available. So the cutting direction, this is pretty straightforward. If you only authorize like horizontal cut along the beam or vertical cut, and here you can actually recover the drop of scrap, what I was referring to earlier. This is the only algorithm at the moment that allows you to do so, because this is the only algorithm that will have actual always rectangular shape leftovers. So here, let's actually run one calculation after another using the different algorithm. With this option, like better result, faster calculation, it's just the number of calculation OptiPanel is going to run before returning the result. At the bottom here are options that are common to all three algorithms. First is the saw blade thickness and the machining cost. This option here, block row panel on attributes, I'm going to show that to you in another example afterwards just for this. It's basically what I was referring to earlier with when I warn you about the making sure that you import all the attributes for all the different production number you have, even if element with same production number may have different attributes, because this allows you actually to block or make sure that no element are optimized in the same nesting volume if they don't have the same information. Here, for example, we are not really going to use an attribute for this one, but we could actually use, for example, the width. So like this, we make sure that we only optimized element of the same width in each of our panel. Then here we have the incremental row panel mode. So this, of course, is only used if you are using panel with incremental length. And there is here different options. We are not going to go or test all of them. I'm just going here to explain to you what they are actually doing. So the first one here, the default, resize each row panel length separately. This means that OptiPanel is searching the best result with all incremental panel dimension. So it's going to try absolutely every single options. The second one here, force incremental row panel to their minimum and ignore the increment. It simply means that, as it says, we ignore the increment and we are only using the shorter panel from the stock. Here, exactly the same, but for the opposite, we are only using the maximal length of our production as set in the stock. So one length for one length increment value, width, material, and thickness. It means that for each of this line, it's going to give you only the possibility of using one length between 30 and 60. So it's just going to make sure that it can fit the greatest panel, minimizing the waste, and then it's going always to use that same length. The thing is, here it's not something that we have here, but let's say that we would have here a duplicate of the same width, and we here allow a actual increment of like 10 inches instead of 6. It's going to use this one here with a specific length and that one here again with another specific length set only to this one. The other one here is simply we are only considering the width, the material, and the thickness. This means that in our case here, these two will be using always the same length because they have the same width, the same material and same thickness. The only thing that changes is actually the increment, which here won't be taken into account. We are just going to make sure that we are using the same length. And then at the bottom, one length for material and thickness. Again, it's the same no matter the width or the increment set. We are always going to try to use one length for one material and one thickness. And here one length and one length and width. Basically for each material and thickness, we want always to use the same panel format. So this all depends on the complexity of your stock and what you want to do. Here we are just going to keep pretty basic and use the default, meaning that we are going to be able to use every single possible sizes as set as in our stock. So here then there is some advanced options like authorize non-incremental panel to have that dimension modified during the calculation. If the stock doesn't fit, it's going actually to adjust always to minimize the sizes. Ignore minimum and maximum lengths wise when resizing the panels. So those are really advanced options that we are not going really to talk about. Those are really pretty specific. Then here at the bottom, user calculating setting. This is not something that you can actually interact with. It's just to show you here what you are currently using. So here we are not going to use pre-processing and using all algorithm. And here it shows you the nesting reference corner. Nesting reference corner is something that you can here visualize, so it will always be here the bottom left are element that will be put against the bottom left corner of the nesting volume, and this is something that you can actually change using here the optimization settings. So here this is simply nesting setting, and here you can actually change that reference, so either bottom or top left or bottom or top right. So let's go forward and run our first calculation. So here you can visualize all the different elements, and you see here you can actually, if you need to, stretch this to have a better visual of the result. And here you see that we have our element. The white area here is actually the rectangular shape that has been considered during this calculation, and here what is like appear to be dashed, those are leftovers, but they are not actually large enough to be saved then in our future stock. This is something that we could see here on this example, and the stock that you can actually reuse will be here with that reddish color. On the right hand side here is a summary of the current optimization, all the elements. So we used the 8 elements, so this means element from the stock. We have a 2000 square feet of panel. We are using 7 row panels, and here we have a overall of leftovers. So on this optimization we have almost 15% and only 7.5% of leftovers that can be used. If needed, you can actually generate a PDF or an HTML directly from this, where you will have your stock, the list of elements, and afterwards here every single detail for each of the nesting result. So you have here everything in text, and then here at the bottom you have specific shop drawings showing you exactly the detail as you would do when exporting shop drawings directly from Cadwork 3D nesting module. The setting for this PDF export are available into configuration, setting, and HTML and PDF. If you are happy with the result, you can actually import that back in Cadwork. Before doing this, let's check the other algorithm. So here, if I'm activating this one, this will take care of the element no matter their shape. So here if we run the calculation here, we might see here maybe better result. So here the thing is, maybe with the stock we've been using, it's pretty much the same result. It was not able actually to fit element in the same. Let's here bring that to Cadwork 3D. So simply click on the Cadwork icon, and when this is done, you can simply close this. Now here we are back in the nesting manager. It shows us here that the element have been grouped and nested. So if we go here in the nesting, in the panel nesting, we can actually here see the result and edit them if needed. Let's check another example with something a bit more complex. So here all of these panels have been added and drawn directly in Cadwork 3D. They are all flat panels of the same thickness. So let's go ahead and export this to OptiPanel to see how it looks. You can directly here send that to the external nesting without passing by the nesting manager if you need to. I'm just going to delete my existing calculation. So here we are back now in OptiPanel, and as you can see here, I still have the stock I've set earlier because I saved that as my init. So it will always here come back when starting a project. You can here always, like as we mentioned, filter away the stock according to different material, and again the same for the thickness. If you don't want to use them during an optimization, you can simply deactivate them. Here again, if you want to activate them all at once, simply make sure to select all the lines to activate them or not. But anyway, in this case, none of the elements we are using are actually using this material or that thickness, so anyway they won't be used. Here I'm just going to load a specific stock that was meant specifically for this example, and I will here open, and here I'm going to load my specific setting. As you can see here, when you open, you actually erase what the stock was previously. If you import, you'll simply add to the existing stock, so be careful about this. So here we have different material, of course, that are not using increment length, so I'm just going to hide this at the moment. And let's go ahead and see a bit the different shape of element we have. So here, the first thing that I want to do is, you see here it says that we should have here along the length. The thing is, actually, we don't want that because these elements, we don't really care about their orientation in the nesting volume. We want them to be able to rotate in any direction to minimize the waste, and then they would be cut with a bandsaw or with a laser cutter, something like this. So let's select everything and actually here set that to none. And let's go back here directly to the optimization. We're just going here to use the polygonal pieces free rotation. So just keep in mind that at the moment this is a still in development, so it's a beta version. Our programmers are still working actively on this calculation. It's a really complex routine. So here, explore the trees of possibilities. It's going to run the calculation for a longer time. And here, saw cut by milling, longer calculation time. It's simply that we want to avoid like the saw to collide with the element. So we are really going to think about this nesting with a milling routine in mind, and so with a route or something like this. You can also force here the rotation only 90 degrees if needed. We are not going to use that. And here we are just going to start the calculation. And so here, after some time of calculation, due to the complexity of these shapes, we have here set a optimization, minimizing the waste of all these elements in one go. So if you are also satisfied with the result, or even if you think that there is some things that you could actually optimize on your end, you can still, again, import that back to Cadwork 3D, and in the nesting module, do any adjustment you would like to do, and then simply export this, export to the XF to 1:1 scale. Up to you what you want to do with that, but here is how the OptiPanel works in the simplest of its detail. I hope this was helpful. See you guys soon.